Hello. So let's continue this unit by talking about prim primitives. No, we're not talking about first year students. We're talking about the basic building blocks, geometric building blocks of graphics. So geometric primitives. So we have some classic primitives. This is classic OpenGL. Things are evolving. It's a moving target. Like I've said before, it's not useful to know the current version of OpenGL or graphics libraries. You just need to be a pro at graphics in general, and then be able to adjust and learn as things change. So in classic OpenGL, we have points. What's going on today? Here we go. Oh, it must be my shirt. We have points. We have lines, triangles, quadrilaterals, and then in general polygons. So we'll talk about each of those in turn. There are other primitives too. Okay, there are other primitives that are not that commonly dealt with, and we won't really talk about them that much in this class. There are circles and there are curves. We'll talk about curves only briefly when we do parametric equations, but in general, they're too slow, basically. In general, they're so slow that we don't bother with them and we stick to these other primitives. So I'm going to switch over to my, if this works, my slide set for a second. So here we go. So this is all the primitives in OpenGL. We have points, we have lines, and then different ways to define lines. We'll explain those later. We have triangles, and then different way to do triangles. We have quads, which is quadrilaterals, and a different way to do that, and then polygon. This is it. These are all of the primitives in OpenGL. In fact, you'll probably not even use most of them. You'll probably just use the lines and the triangles and maybe the points. Excuse me, and be done with it. Okay, let's go back. So let's start by talking about, oh yes, I do have a side note first. Note on precision. As you now, precision, I probably spelt that wrong. As you now start to move towards building things, there's one small thing I want to share with you. Is the idea of when you use floating point precision numbers, we have these floats versus doubles. In 1010, when we teach this stuff, often students put their hand up and say, then why are we even bothering with float? Right? Why would we use less precision? Well, because it uses less memory and it's quicker to do operations on. So even though doubles are really important if you're doing anything precise or scientific computing, in graphics, because often we're okay with things not being quite precise, we want them to look good and go fast, we often make that trade-off. So processing has been set up to default to float. Not sure what happened there. It's almost like I have an object there in a way. Well, computers, hey? Graphics, hey? So processing defaults to float, and so you don't have to convert all your floating point literals to float manually. It'll just happen naturally in processing. But in Java, if you do this in Java, Java uses doubles. Yeah, that's interesting. Cool. Oh well. We'll let that sit there and hope nothing blows up. So yeah, you need to just be aware of that, and sometimes it creates a few quirks. Some people are starting to use doubles, but again, it's double the memory. It's a lot slower to work with. We can get away with just using floats. So let's talk about points. Okay, I'm going to pause and restart my app here. Something's broken. Okay, we're back. Crashed hard, and I had to recreate some of those notes, but we should be good. So I'm going to start by talking about points. Now, points are, as you might expect, they're just a place, a point in space. You use points if you want to place a point in. I was just saying. There we go. Okay, place a point in space. All right. Now the idea in your mind is generally how big is a point. OpenGL typically tries to make it about the size of 1 pixel, so you often use this to set 1 pixel in the frame buffer, right? You set that memory to the value you want, 1 pixel in the frame buffer. And I will put a red asterisk here because it can actually be hard to achieve that. It can be hard to achieve just that 1 pixel. And the reason for that is depending how your OpenGL and your graphics card and your everything along the way is set up, we have a lot of anti-aliasing, correction, etc. going on. So it can actually be really hard sometimes to get that 1 little pixel that you want. In fact, there's a term for this. If you want to get things exactly pixel by pixel, we call it pixel perfect. So if you're doing raw OpenGL and you have access to all the flags and all the configuration, you can do it. I'm sure you can do it. It's not a problem. It's just a bit of a hassle. In processing, where we're 1 step higher and it's more difficult to get access to those flags, sometimes you're going to put a pixel and it'll look anti-aliased, okay? Just wanted to raise that flag. So what does it look like? Yeah, what does it look like in OpenGL? So we can just do our begin shapes, which we've seen before. But this time the shape that we begin is points. They're all capitalized because it's a constant. Begin point, shape points, semicolon. Now remember, OpenGL is stateful, so even though you don't have like a bracket or a subsection, after your begin shape, everything you put needs to be for that shape until you do an end shape. It's stateful. So inside your begin shape, we can put a vertex, for example, at negative 0.5, 0.5. Another vertex. Let's do this one at 0.2, negative 0.1, etc. And you can put as many vertices as you want, and then when you're done, you end your shape. Just like that. So 1 vertex, 1 point. Okay. So yeah, let's do a quick demo. Let's do a quick demo on that. Let's see if I can get this to work. There we go. So here's our demo. Everything should look familiar here. We set up, use P3D, set our background color. Now we can set I'll come back to this in a second. We can set our stroke color for the points. We begin the shape, we put 4 points on the screen here, and then we end the shape. See how that looks. Ta-da! You can't see that because it's a video. But there's actually 4 points on my screen. There we go. How's that? And if you look closely, I'm not sure if it comes through in the video, the points, they kind of look like angles. They're kind of not really points. Again, we're talking anti-aliasing happening here. Like I said, pixel perfect can be quite difficult, but it's essentially a point. So we can also draw bigger points. We can tell our engine that let's not do a pixel size, let's make it bigger. In processing, they overloaded their existing system, so we use stroke weight, not width. Stroke weight, right? And we give it a float. In OpenGL, It's a P. OpenGL, we use GL point size. Okay, just like that. And if I go back to our demo, we can see that working. So here, let's close it. I can set my stroke width to 15, so it'll be 15 pixels. There's a comment here showing how you can't change how it fills. Like, it's not making a circle. It doesn't fill it differently, even if we change the fill color. But it'll just make 4 points. And this time I probably won't have to zoom in because I made these big honking points. There we go. See, we can make the points as big as we want. Cool. Now, one thing I want to mention here that you might have noticed already is that these vertex points, the coordinates really does depend, of those points, depends on your coordinate system. So let's make a note about that. And one problem is, how big is one pixel anyway in terms of your coordinate system? So let's think about that, right? I have my screen, which goes from minus one on the x-axis to +1. So that range is -1 to 0 all the way to +1. So there's a range of 2. But I have like 640 pixels. So each pixel is only a very small value. So if I zoom in, and this is my grid, and this is 1 pixel. 1 pixel here, you know, this might be coordinate 0.00, how many zeros have I got there? 15000, that's a point there, you know, 27 or whatever. These are really small numbers. Any coordinate within that range will fall into that pixel. When we're dealing with floating point numbers and not just integers for our pixels, you have this issue where a lot of values will point to the same pixel, okay? And it's not really a big deal, but I wanted to mention it. Anything inside this region lights the pixel. Okay. Cool. Now let's talk also, or maybe I'll take a break there and we'll come back and do lines in a second.